Well, welcome everybody. My name's Jim Chisholm. I'm PEO counselor and also the former coordinator of the AdHocClimateChangeGroup. Today we have an excellent seminar on the topic of regulatory action in relation to climate change on buildings. And this, as I mentioned, is organized by the AdHoc Climate Change Group. It's primarily a group of PEO members that have come together on the issue of climate change. And it is the 13th seminar that this group has organized on the topic of climate change. Our purpose has been primarily to give information to PEO members on climate change, with the hopes that it will put the issue more on the radar of the PEO, and eventually that they in fact will see this as a very significant regulatory public interest issue that they need to have an action plan on. So a couple of housekeeping items. Number one, this meeting is being recorded. And number two, if you have questions, we have a Slido process, and somebody will describe that after I speak. They can write down your questions. So at this point, I'd like to hand it over to our main organizer of this seminar, and that is Christy. Christy.
Hi, thanks, Jim, for your introduction. Hello, everyone. I'm Christy from Ottawa. I'm the current lead of the AdHoc Climate Change Group. I'm so excited to have you here tonight to learn, share, and discuss our climate change group issues, some climate change challenges, and potential solutions to climate adaptation and mitigation. I would like to start my introduction for this seminar by acknowledging that we are meeting on Aboriginal land that has been inhabited by Indigenous people from the beginning. I want to show my respect for their contributions and recognize the role of treaty making what is now Ontario. Hundreds of years after first treaties were signed, they are still relevant today. We are grateful for the opportunity to meet here, and we thank all the generations of people who have taken care of this land for thousands of years. Climate change is becoming a significant topic, and we cannot avoid and should take actions as soon as possible. This seminar is organized under a group of people at the Professional Engineers Ontario who care about climate change issues and really want to make a difference based on our multidisciplinary background. Our mission is to help engineers, practitioners, academics, decision makers, and regulatory committee members to set a vision and work on action plans and treaties and the strategies for climate change and for climate change adaptation and mitigation in Ontario. Now I will pass my torch to Louis to introduce our guest speakers.
Thank you, Christy. I think that before to introduce the speakers, I will introduce P.Eng, that she will explain how it will work the Slido process for the questions to the speakers.
Perfect. Thank you, Louise. Thank you, Christy. Good evening, everyone. Thank you so much for joining us tonight. My name is P.Eng. I will be the question poll and panel discussion moderator for tonight's seminar. Just to kick off tonight's seminar, we have a poll with 3 questions, and we have a Slido channel link I posted in the group chat, but I will also share my screen. You can scan the QR code to log in the Slido channel to participate in the poll and post your questions on Slido. Can you see my share screen, Christy?
Yeah.
Perfect. So yeah, before we kick off our seminar tonight, we prepared 3 questions. The first question is, what is your role related to the building sector? I'll read the questions out loud. Probably I'll give a minute per question so that we have time to make our decisions. The first one is building owner, operator, manager, consulting engineer, contractor, installer, or service technician, equipment supplier / vendor, regulator, utility, and other. Just here to learn. I can see there are 11 people participating in this poll. I'll wait for 20 more seconds just so that people can log in their Slido and make their decision. Thanks again, Christy, for sending that Slido link. And if you have any difficulty accessing the Slido link, please let us know. All right. We'll head to the question number 2. Question number 2, there are 6 sustainable building design principles defined by National Institute of Building Science. So from your experience, which is the most challenging to achieve? Optimize site potential, optimize energy use, protect and conserve water, optimize building space and material use, enhance indoor environment quality, optimize operational and maintenance practices. Let's see if we can hit 15 people participating in this. Perfect. I'll wait for 10 more seconds before heading to the third question. All right. Last question. From your perspective, what are the biggest roadblocks to catalyzing building sector decarbonization and resilience? Client not interested, client not engaged, consulting team not sure about best way to proceed, budget and time constraints, technical challenges, organizational constraints, regulatory, and last one is other. Perfect. Let's see if we can get 17 people participating. That's perfect. All right, I'll close the question poll for now. And thanks everyone for participating. Hopefully we'll carry those questions through the presentation tonight, and we'll share the results at the end of the presentation for our panel discussion. Thanks everyone for participating. Luis, I'll hand it to you for introducing our guest speakers.
Thank you, Christy. I will start introducing our first speaker today. Our first speaker today is Harshan. He's a professional engineer registered with Engineers and Geoscientists BC and APEGA with more than 10 years of experience in environmental regulation, oversight of regulatory programs, as well as in-depth understanding of the municipal, provincial, and federal regulatory requirements. He provides staff support for engineers and geoscientists, visits climate change and sustainability advisory groups, and plays a key role in supporting the implementation of engineers and geoscientists VC in climate change action plan. As the manager, climate change and sustainability initiatives, Harshan deals with management of programs and initiatives that helps to address sustainability and climate change adaptation and mitigation in the practice of the professions, and outreach the provincial and municipal governments, technical groups, and others in relation to climate change and sustainability strategies. The title of his presentation today is the role of the regulator, bridging silos to catalyze the decarbonization and resilience of buildings. With all of you, Harshan.
Thank you so much, Luis, for your kind information. I'll just note that I'm speaking to you from my work today, which happens to be in the traditional and unceded territories of the Musqueam, Squamish, and Tsleil-Waututh First Nations. There's maybe a little bit of background noise, but please bear with me for the next 20 minutes as I go through what the potential role of regulatory bodies such as Engineers and Geoscientists BC could be in relation to bridging silos to catalyze decarbonization and resilience of buildings. Before we jump in, I just wanted to provide perhaps a little bit of encouragement to say that certainly addressing decarbonization and resilience is not rocket science. I have individually taken every advantage of the opportunity with the federal and provincial incentives to decarbonize my own household, decarbonize the way I move, and certainly looking into additional opportunities to boost resiliency at my own household. But what we could potentially achieve together as the regulatory body, as the registrants of the regulatory body, is quite something. It's of an order of magnitude that's perhaps at the scale of what is needed to achieve ambitious climate action. With that said, I will jump into the presentation. Many of you may know about Engineers and Geoscientists BC. Similar to the Professional Engineers Ontario, we have the mandate to protect the public interest, respecting the practice of professions. And we also have the responsibility to respond to and adapt to changes in practice environments, advances in technology, and other emerging issues. To deliver on this mandate, our strategic plan establishes a new vision for the organization, modern regulation for a resilient world. The plan would guide our decisions, steer our operations, and shape our future as an inclusive, progressive, and future-focused regulator. Shown on the screen is one of the strategic imperatives on social responsibility, where we have identified that promoting reconciliation, promoting equity, diversity, and inclusion, and taking action on climate change are all equally important work we will undertake in pursuit of this vision. So in preparing for this presentation, I wanted to see what is the flavor of the regulatory considerations as it pertains to climate change. And I dug up, and I'm happy to share 3 examples here to provide a broad snapshot of the various kinds of regulators, ranging from the financial to professional association to utility regulators. We can begin by talking about the Office of the Superintendent of Financial Institutions. Some of you may be familiar with the work done by the European Union and US Securities and Exchange Commission in terms of establishing requirements around disclosure reporting. And in particular, climate-related financial disclosures. Canada has followed suit with the OFSI establishing requirements that federally regulated institutions, which include everything from domestic to national banks to trust companies to estates, pension funds, all of these federally regulated entities should now be thinking about and disclosing how they are managing their physical risks and transitional risks. For those that do not know what transitional risks are, those are climate change related risks that result from changes to market, changes to public policy, changes to technology, changes to legal aspects, as well as reputational risks. And what this work, the establishment of climate risk management guidelines will do is it will reverberate across the market space in terms of more green loans being available, more activity from the financial sector to sort of look at how they can decarbonize their portfolios, as well as make sure that their lending strategies are resilient to the impacts of a changing climate. Now, let's switch gears and look at what a utility commission can be doing. They are a regulator responsible for regulating BC's energy utilities. And their mandate is to make sure that the utilities that they regulate, they're able to protect the interests of the customers. But given that BC government has GHG reduction targets for the energy delivered by public utilities, BCUC is requesting their regulated entities to share their long-term resource plans to say, how are you meeting the needs of the long-term energy transition that is underway? And if we look at other professional associations like the Chartered Professional Accountants of Canada, as well as BC, they have a portfolio of training and resources focused on ESG, task force for climate-related financial disclosures. And essentially, they're working with city governments, local governments, and providing them with tools to help inform how they can determine what sort of climate-related information is valuable for internal decision-making and how they can leverage this information for both short-term budgeting as well as long-term capital planning. So as you can clearly see, there is a role for regulators, and the role as it pertains to the regulator can be clearly defined as it relates to the mandate of the regulatory body. So I just wanted to share that. As it comes to engineers and geoscientists BC, we have a council established, council endorsed climate change action plan that is now integrated into our strategic plan. The plan has twin complementary goals of supporting registrants with effective management of climate risk and developing and implementing solutions to reduce GHGs. So the plan really is a first of its kind across engineering and geoscience regulatory bodies, and it is meant to be a model that can be easily adopted by other regulatory bodies as well. And if we look at some of the action areas, it really is focused on supporting and encouraging and establishing conditions in which taking action on climate change is enabled. It does not mandate or direct or create an additional regulatory burden onto our registrants, because it fully reconciles with the fact that our registrants work for a variety of stakeholders and in a variety of sectors. And the effective way for us to support them is through leadership and collaboration. It's through looking at registration and competencies. it's through enabling knowledge sharing, and it's through the development of practice resources. And quickly, I'll tell you in the next few slides about how the implementation of the climate plan is going ahead. For example, we have carried out an extensive stakeholder mapping to make sure that we are able to reach out to various stakeholders and groups, such as governments, indigenous and technical groups, and others in relation to climate change and sustainability strategies. And when we developed the climate change action plan, we were informed that there are lots of engineers working as climate solutions engineers, working as climate action implementation leads within governments, within consulting sector, within industry, and they wanted greater recognition for the work that they're already doing. And while we already had other areas of practice related to energy use assessments, GHG calculation, and sustainability, and so on, in recognition of this new and evolving practice areas, we've introduced 2 new practice areas on climate risk management and climate science. And you can see here that it hasn't even been a year since these practice areas were declared, and there's been a robust uptake because of the practice guidelines that Engineers and Geoscientists BC has already established in this space. And we take it upon ourselves to make sure that we actively leverage our branches and divisions and subject matter experts to enable knowledge sharing on a wide range of climate change and sustainability topics. Not just that, through the way we sponsor other conferences and events, through the way we engage with other stakeholders, we effectively leverage opportunities for knowledge sharing to make sure that our registrants are kept up to speed in relation to the evolving climate change and sustainability public policy space. And practice resources is one area where Engineers and Geoscientists BC has done quite a bit of work over the number of years, especially because we have the mandate to establish, monitor, and enforce standards for professional practice. Some of the examples that you see on the screen relate to the building sector, but we have practice guidelines that deal with a wide range of sectors and areas of practice. And every time we develop new practice guidelines or revise existing ones, we apply a climate lens to the development of these resources so that they reflect the current challenges and opportunities that our registrants have to address by professional practice. And in over the next few minutes, I'd like to talk about what are the regulatory actions that are currently in effect in BC, what are some regulatory drivers that are in the horizon that could impact the work that engineers do, and some market opportunities where we can effectively leverage these opportunities to mainstream climate action. So in terms of regulatory action, some of you may be familiar with the fact that the BC Energy Step Code was introduced as a voluntary standard that has been integrated into BC's building code. Now, this Energy Step Code provides a performance path approach to energy and emissions reductions, ranging from all the way from base building code progressively leading to net zero ready by 2032. And it is a real success story that I can share today, because the voluntary standard has been adopted in a policy program or a bylaw in over 80 local governments across BC. Not just that, if we look at folks in the social housing space, or the work done by academia, or work done by cities, we can see the progression in terms of changes to design standards and construction standards that reflect both the need to decarbonize as well as the need to make buildings more resilient. BC Housing in particular has secured funding, federal funding, to develop a portfolio of resources under their Mobilizing Building Adaptation and Resilience program. And they make these resources freely available. And the cool thing is that they also deliver training for builders and developers. And these training materials have permeated so that the building officials have also started to take that. And there's a real synergy in the work being done in BC to the effect that it's being mainstreamed. And City of Vancouver, they have been a true climate leader right from the get-go. They had the most stringent emissions requirements. They were the first ones to introduce GHGI requirements in a building policy or bylaw. What they've done of late is that they moved the requirements which applied only to their rezoning policy to be more broadly applicable to VBBL. So in fact, if you build a new Part 3 building in the city of Vancouver, you will have to build it so that it's near net zero in terms of operational emissions. And on top of that, they've introduced requirements that you have to report on in relation to embodied carbon. So that is the regulatory space that exists today. It's already well underway, but we could be talking about some of the regulatory drivers that is spurring the action. If we look at the Clean BC roadmap to 2030, particularly in relation to the building sector, the roadmap commits to reducing emissions from anywhere between 59 to 64% from buildings and communities from 2007 levels. It also commits the province to implement a 100% clean electricity delivery standard for the BC hydro grid, a new program to support local government climate and resiliency goals with funding to boot. So that's one aspect. They're operating at multiple levels, which means that their energy efficiency standards and regulations are evolving as well, to the extent that all space heating and water heating equipment sold and installed in BC after 2030 is to exceed 100% energy efficiency, which means that conventional combustion equipment may no longer be installed. And there's also commitments in there that 90% of new vehicles sold be zero emissions vehicles by 2030 and 100% by 2035. Arguably, that's not related to the building sector, but it has implications for the electric vehicle charging infrastructure that will need to be deployed in buildings and parking lots. And there's also, they're looking into carrying out modeling and analysis to establish caps that will be set on utilities so that they are able to progressively drive down emissions from electric and natural gas utilities. And there are several energy efficiency programs and incentives available so that this whole aspect of energy poverty, accessibility, affordability doesn't get lost in our pursuit to drive emissions down and make buildings resilient. I already told you about the incentives that I have accessed. Some of you may be most familiar with the Canada Greener Homes initiative. I've certainly personally benefited from it. But if we look at some of the other market opportunities that are available, the Canada's Infrastructure Bank, it provides financing for energy retrofit projects for both public sector as well as private sector by way of vehicles like direct investment loans, working with mortgage lenders, or through special purpose vehicles. Some of you may have heard about the property assessed clean energy programs. If we look at FCM, the Federation of Canadian Municipalities, they have few different funding opportunities that are available that target GHG reduction measures that apply to groups of buildings or to certain local recreational and cultural facilities to the extent they achieve certain GHG emissions reduction within a certain timeline. They are eligible to get that retrofit funding opportunity. And suffice to say that there are multiple programs and resources that also provide funding opportunities and support for energy retrofits and new builds for Indigenous communities. One of the other things that is happening is the establishment of the 2030 districts across North America, and certainly there's even a 2030 district in Toronto, if I recall correctly. The one in Greater Victoria is hosted by BOMA BC, and what it targets is they've been able to bring together 38 buildings and 3.7 million square feet of space represented by major property managers. Each member of the district has committed to participating buildings to meet 50% reductions in energy and GHGs as established by the Architecture 2030 in its 2030 challenge for planning. And hopefully Mehdi will touch on similar initiatives led by City of Toronto. So what I'd like to leave you with is that, it is a real opportunity. With climate action, there are several considerations that come into play, like carbon leakage, geopolitics and things like that. But if we look at the building space, all of the real estate exists within Canada. There's no, we don't have to worry too much about economic competitiveness or anything like that. In fact, catalyzing decarbonization and resilience represents a golden opportunity to mitigate risks, stimulate the local economy, and realize co-benefits in human health and well-being. And we can build on successes. There's no need to reinvent the wheel. Implementation in BC provides a role model for upscaling and mainstreaming the approach to building low carbon and resilient buildings. And finally, engineers, we all work for a variety of stakeholders, working for regulators, policymakers, and part of civil society. It really is an opportunity for us to assume the responsibility and work collaboratively towards market transformation. Thank you so much.
Thanks, Harshan. We would like to transfer to Lois to introduce our second speaker, Mehdi.
Hello, everyone. It's time for our second speaker tonight. The second speaker is Mehdi. And he's a former senior engineer in the City of Toronto, implementing Toronto's energy and environmental policies in the built environment. He led the development of the Toronto Renewable Energy Strategy with focus on market development guidelines and identifying effective business models to scale up implementation. Mehdi has over 14 years of experience working in academic, public, and private settings while foresting sustainable development as a means for climate change adoption and economic and social prosperity. Welcome, Mehdi.
Thank you, Luis. Good evening, everyone. It's a pleasure to be with you tonight, speaking to engineers all across Canada. I'm going to share my screen now, but before I get started, I'd like to take a step back, and thanks Harshan for the great presentation, great start to the conversation for tonight, focusing on climate change regulations and the role of regulators. I will be focusing more on the sustainability side and how sustainable development can be a pathways for climate change adaptation and mitigation. Then I will start with kind of highlighting the importance of the Sustainable Development Goals from the United Nations that basically has targets for 2030 for a world that meets the close to 232 indicators of sustainability that spans from ending poverty and hunger, access to education for all, building sustainable communities and cities, infrastructure development, decent jobs, decent and well-paying jobs, climate change, biodiversity laws, life on Earth and life in the sea, and a few other indicators, as you can see on the screen. The progress of the Sustainable Development Goals are basically tracked by the United Nations and published annually. And as you can see on the screens, this is from some screenshots from the 2022 report that came out last summer. And obviously the results in the past year or two have been impacted by the pandemic. But regardless of the pandemic impact, we still have billions of people around the world without access to clean water, access to electricity, access to clean energy for cooking, sanitation systems. And as you can see on the graph to the top left, within the past 60 to 80 years, the world's population has doubled, and the dwelling preferences have been shifted from rural population to urban population. That's where the jobs are. That's where the infrastructure is focused primarily by governments around the world. But then at the same time, urbanization provides its own opportunities because, as we know, cities are the economic and political hubs of the world. We have surpassed the 50% share between urban and rural dwellers, where in the city, the majority of the global GDP is generated in urban areas. Policies are made in urban areas, and then by the same proportion or even higher, the resource consumption and consequently GHG emissions primarily come from cities. And so therefore, sustainable urbanization is critical, especially when you want to address issues such as housing, jobs, equity, hunger, and poverty. And also in the presence of climate change and the extreme weather events that's impacting both, that's impacting us globally, then focusing on issues such as resilience, improved sanitation, access to reliable and clean energy, including for cooking, are of paramount importance. Where then one of the issues is that most cities currently are focusing on greenhouse gas emissions, and then we have, I would say, globally in major cities around the world, there's great reporting of greenhouse gas emissions, and some of the underlying parameters as well, such as energy consumption or even local air quality of such. And then within the cities, primarily the emissions come from first the building sector and then the transportation sectors. So those are the two main areas that that emissions come from. But then in order for them to basically tackle the issues of climate change and the consequences of it, the majority of the cities around the world, as you can see, they focus on energy transition. So basically transitioning from fossil fuel to low carbon energy sources, and also resource management. And the resource management can focus on energy efficiency and conservation, also waste management. And they do that through primarily voluntary mechanisms, basically by designing voluntary guidelines or requirements, such as green standards for buildings. And some municipalities have the luxury of being able to set ordinances in order to basically meet some of these requirements that they have in mind, but primarily it's mostly through voluntary actions. And some municipalities can work with the utilities and solution providers with actions such as purchase power agreements to move some of these initiatives forward. But then before I move to the next slide, I want to basically circle back and say that, yes, sustainability is the broader scheme, is the broader criteria that we will have to collectively look at. Climate change and the indicators within the sustainable development goal for climate change, including resilience and an investment in education, as Harshan mentioned, that one of the primary work that him and his team are doing is focusing on educating folks on climate change initiatives. Those are the indicators and the parameters that are important within the broader SDG or sustainability. But then cities on their own, they are the ones, as I said, as the economic hubs of the world, they're the ones who move forward to take the lead on such initiatives, right? Although, as I mentioned again, they're primarily focused on GHG emissions, and then everything else comes as added benefits or other benefits of such initiatives. And as we know most recently, the issues of justice and equity and resiliency have been put forward as more basically highlighted, and almost all cities are trying to address those issues, along with the issues of GHG emissions reductions. So take New York City, for example, Local Law 97. It's a great basically bylaw that sets emission caps for tall buildings, and starting 2024, buildings that emit above the cap, they would have to pay close to $300 a ton for their emissions. And then in 2030, that emission cap is going to be more stringent, so the penalty is going to be much higher. Now, the industry is working closely with the city in terms of how to meet those requirements, right? The city itself, when they set regulations like that, they try to also help the industry, help the public with understanding the consequences and how to basically comply with the requirements. Building Energy Exchange is one of those platforms. It's that's been developed by a few public entities and the private sector. And this is just one of the examples that you can enter the address of a building in New York City, any building that you have in mind, and it tells you what the penalty is in 2024, from 2024 to 2029, and then what's the penalty is afterwards. I mean, if you look at buildings such as the Empire Building, Empire State Building, you realize because of how efficient and low carbon the building is, even past 2030, that building will still not have an emission penalty. Other ordinances and local laws within New York City, as you can see, a building is subject to several energy requirements, and the city is also helping the building sector basically with developing guidelines on how to comply with these requirements. New York City is one of the cities that you can publicly see the energy rating of the tall buildings under entrance. So when you just walk on the streets, you can see that the building can have a grade A or grade C. Lighting requirements for public for common elements in the building. That's local law 134. I talked about local law 97. That's the building emission cap. But then one of the recently announced and important and significant local laws in New York is 154, and that's basically all electric buildings for new construction, right? So that impacts almost all forms of new construction within the city. And then, as I said, with support from the city and other government and public entities and the private sector and not-for-profits, basically the industry is moving towards a direction to meeting these requirements and complying with them. So there's support provided. Some of the links at the bottom that you can see. One of the supports that's available for folks in New York is through the Empire Building Challenge, where a significant amount of funding is available for tall developments to basically meet their to get ahead of the curve and showcase themselves as leaders in emission reduction, building resiliency, improving local air quality, indoor air quality, and other indicators. And basically that's for to spur economic growth and renewal in New York City through these partnerships. And through the Empire Building Challenge, there's great resources available for practitioners and also for building owners and operators to figure out how they can achieve the highest, or basically the highest level of excellence in the building performance. One of the best ones that I can refer to is the Empire Building Playbook, and that basically provides a guidance and a guideline for the industry on how to approach a complex building in order to get to the highest level of energy and emissions reduction. There's other resources and also funding mechanisms are available. So the point there is that when there is a regulation and a requirement, there also needs to be available guidelines, funding mechanisms, so that so that meeting the regulations and the requirements is going to be, or the policies is going to be natural and organic, without basically reducing sustainability of the built environment and reducing the negative impact on the building owners and operators and also building tenants. Another great example is City of Toronto. The Toronto Green Standards has been operational since 2018, and the plan for it is to be net zero by 2030. The city has made significant progress there is greater than 90% compliance from the development industry in meeting the Toronto Green Standards. Each tier which is mandatory through the rezoning application and the planning approval process for new development. The Toronto Green Standard falls under the Transform TO, which is the city's climate change mitigation and adaptation policy for 2050, right? And that's why the City of Toronto also provides guidelines to the public and to practitioners in order to meet those requirements, and works with them. So every time a resident of Toronto or a developer or a business owner would like to take action or meet some of these requirements, there are resources available within the city to support them. And one of them is the zero emissions buildings framework that kind of highlights one of the approaches to be able to meet the requirements of the city, and then kind of highlights some of the costs. And resiliency is also an important element or indicator for the cities. That's why the minimum backup power guidelines for multi-unit residential buildings, it was first published in 2016 and currently is going through through a revision. And the minimum backup power guideline basically guides building owners on how to develop a resilience strategy for their building by including some critical loads within the emergency power system for extreme weather events and times that there's a blackout in the electricity grid. So those are mainly focused on building level projects, but as we know, the progress is slow. Even the SDG reports indicates that if we really want to meet the 2030 climate goals, we will need to more than double our current efforts, at least on the energy efficiency and conservation side, and basically improving energy intensity of technology such as batteries. So getting to urban sustainability, meeting climate goals, making sure that cities are livable for all from all perspectives, we need to get to scale. And one of the ways to get to scale is through district energy systems. We have district energy systems in the Vancouver area. City of Richmond just got an agreement with Canada Infrastructure Bank to expand their existing district energy system. N-Wave in Toronto has been doing a great job. In New York, the focus on district energy system is growing. There are programs available for municipalities and for building owners and developers to focus on district energy systems. There was a law passed a couple months ago that basically mandates the investor-owned utilities to focus on district energy systems and bring it into neighborhoods. That's just not for a district system. Focusing on technology and bringing technology to scale is another important element. Partnering with manufacturers and innovators to bring in packaged terminal heat pump units that you can hang easily from your window to support and supply a portion, if not all, of your of a multifamily residential units heating requirements in the winter at low cost, has been the focus of New York as well in the past couple of years, and it's going in the right direction. Another example of bringing this transition to scale, you probably have heard of the world's largest sewer heat recovery project. That's the Toronto Western Hospital partnership with the between a solution provider or energy developer, the hospital, support from private funding institutions, public funding institutions and support from City of Toronto to bring this to fruition. Subsequent to that, the city is focusing on scaling these types of projects and has created a GIS map that shows where the main load nodes for district energy systems are, what's the capacity, and also what's the approval process for any building developer or any building owner or project developer who would like to focus and basically install such systems. So circling back on the topic of sustainability as the primary umbrella over the work that has to be done for climate change, we know that most municipalities around the world, and these are just some examples that I've shown here, have 2050 climate plans, if not earlier. They focus on greenhouse gas emission reduction within their energy system, the transportation and the building sector. They focus on resilience, focus on outdoor air or local air quality. Some focus on affordability, for example, or housing affordability or energy affordability. But unfortunately, none of those cities focus on on all spectrum of sustainability, which has two elements. There's a biophysical element, which as you can see in the graph to the top left, includes geophysical risk, climate change, biodiversity loss, freshwater use, land use change, and nitrogen cycle and pollution. And then also it should include other elements or other indicators, the socioeconomic one that focus on security, youth unemployment, economy, energy density, mobility, institution, and yeah. So what you see on the screen is how cities around the world perform compared to the planetary limits. So the inner circle is actually the indicator of the planetary limits for biophysical and socioeconomic limits of sustainability. And then, as you can see, on most indicators, we are actually beyond those limits. So meaning that we have to do much better in the next 10 to 30 years to basically being able to reduce our sustainability impact. And what we can do with this is to use the same sustainability indicators to develop a new tool, and that tool will be a sustainability assessment for urban infrastructure. So currently, primarily economic considerations are the driving focus for designing a new infrastructure or selecting a certain type of a certain project, whereas resiliency has become an important part of that decision-making process as well. But looking at sustainability and being able to figure out how sustainable an infrastructure project is compared to another one, or in terms of options or design, is something that we need in order to be able to build sustainable and livable cities that can be built based on the Sustainable Development Goals and some other standards, and basically identifying specific indicators for the city and for the project, and can also have the same form as the marginal abatement cost curves that have been available for many years, for the past 2 decades, for decision makers to focus on infrastructure development and policy development on a carbon level. So this will be focusing on infrastructure and policy development on a sustainability level, so that we make sure so that we can make sure we have covered all aspects of sustainability in our infrastructure planning decision-making process. So with that, yeah, that's the end of my presentation. Thank you, and These two graphs are for the city of Toronto. So if you just take a quick look, you'll realize that we're way beyond the planetary boundary in the city for issues such as climate change, nitrogen cycle, and risk of biodiversity loss. But we're doing much better on the socioeconomic limits of sustainability. Thank you.
Thank you very much, Mehdi, for all the information that you provide to us. Now we will continue with the last speaker tonight. The last speaker tonight is Christy, and she is a BC-based senior project manager at RDH Building Science, with an emphasis on efficient building systems, research, and sustainability. For the past 20 years, she has been designing, evaluating, and researching about energy, carbon, and water-efficient solutions for the built environment. Her current focus is in improving the performance of existing buildings through applied research and supporting the development of related policies and programs. The title of the presentation is Climate Action for Engineers. Welcome, Christy.
Thank you, Louise. I'm just going to share my screen. Okay, I'm really impressed by your members' commitment. You're getting well into your evening. I hope you at least have a favorite drink or some nice snacks to get you through the next hour. So thanks for the introduction, Louise. I am based in Victoria, BC, and yeah, I'm going to talk about climate action for engineers, kind of building on what Harshan and Mehdi have presented and sort of zooming down into the building level. So really quick, who is RDH Building Science? Our mission is to make buildings better, and that covers new buildings, existing buildings. I've listed a bunch of things that we do on the slide here. Energy and carbon analysis, design, construction management, asset planning, basically anything throughout a building's life cycle. And we do also have offices in Toronto and Waterloo. So if you're in the neighborhood, stop by and say hello.
Hello, Christy, we cannot see your screen sharing.
Oh,
okay. Make sure it works. Thanks.
Okay. There we go. Let's try this again. Thanks for interrupting me. Can you see it now?
Yeah, perfect.
Okay. You didn't miss anything. So I've sort of framed my time with you around the key question of what climate action means for engineers working in the building sector. And I saw that many of you are consulting engineers, so that's really sort of the perspective I'm bringing. Like, what does this look like in the kind of work that I do every day? So first, I'm going to talk about the key levers that we have available to us to enact climate action in our work, and then I'll illustrate how those are applied through some project examples. So I think the other presenters have touched on this, but there's kind of two key elements to this crisis that we're in now. Buildings need to both adapt to a changing climate while at the same time mitigating emissions. So just to ensure we all have a common understanding of what we're talking about in the language, adaptation is really about anticipating and adapting to the adverse effects, or sometimes they're even positive effects of climate change, and taking appropriate action to minimize any potential damage that can be caused by that change. Whereas mitigation is taking actions to reduce our greenhouse gas emissions. I'm going to talk about each of these in a little bit more detail. So within the building sector, we have kind of two main categories of actions we can take to mitigate emissions. One is through operational carbon, and the second is through embodied carbon. when it comes to adaptation, it's really about understanding future environmental loads, future extremes, and then incorporating those into our design decisions. So that ideally, I'm just going to find my pointer here. Where did it go? Oh, maybe not. Ideally, so if we've got mitigation on the x-axis, adaptation on the y-axis, we're identifying solutions for new buildings, and I'm talking existing or new buildings that are kind of in this top right quadrant that are sort of maximizing both mitigation and adaptation. And I'll give you some examples of those later on. Well, there's my highlighter. I found it. Pointer. There we go. There's my laser pointer. So I'm going to zoom in a little bit more first on the sort of mitigation aspect. So if we think about specifically about a building and its life cycle, this is really a simple graphic that illustrates how embodied and operational carbon contribute differently at different phases of a building's life. So when it's constructed, there's a big impact in terms of embodied carbon. So all the carbon emissions associated with the manufacture, transport, and construction of materials that create a new building is very significant. And then once the building construction is complete, then you move into an operational carbon phase where your emissions are associated with the energy sources that you use to operate the building on a day-to-day basis, whether that's a cleaner electric grid-based energy or fossil fuel-based energy. They all do have a carbon impact that will vary. And then presumably at some point in the building's life, you will undertake end-of-life renewals. So there will be embodied carbon impacts to replacement materials, cladding, windows, mechanical equipment, and then also associated with the removal and demolition of materials. And then you're back into a cycle of operational carbon. So two main ways to reduce operational carbon. One is to reduce building energy use. So designing energy efficient buildings and retrofitting existing buildings. So the kind of general mantra is that regardless of the fuel type you use in a building, reducing energy is always a good strategy. The state of Washington has adopted this approach with existing buildings. They have a regulation now that has adopted ASHRAE 100, which is an energy performance standard for existing buildings. It basically says you must achieve certain levels of energy use intensity by certain years, depending on the building type. So they've taken the approach of being fuel agnostic and focusing first on energy efficiency. And the second opportunity is to select low and no emission energy sources where possible. So in terms of reducing energy use, it's an exercise of understanding what your main energy uses are in a given building. In many building types like multifamily buildings and offices, heating energy is the big one. Other building types like say a large retail building, lighting is a very big proportion. So understanding what those major end uses are and then focusing on ways to make those systems more efficient. And then when it comes to the energy sources, you kind of have this spectrum of opportunities where the highest, both the lowest efficiency and the highest emissions energy sources are fossil fuel combustion. So natural gas, oil furnaces, that sort of thing. And kind of in the middle, you have electric resistance-based options, which the impacts in terms of emissions will vary depending on how clean your grid is. In BC, we have a lot of hydroelectricity, so the emissions are fairly low. From what I understand in Ontario, I think you have a bit more coal-fired electricity currently. And then on kind of the far right here is any sort of electric heat pump based solutions, assuming you have relatively clean electricity, is generally going to sort of win out in terms of both energy efficiency and emissions, because their coefficient of performance is much greater than either electric resistance or combustion fuel sources in almost all situations. So opportunities to reduce embodied carbon, really it's about reducing the emissions associated with building materials. So using fewer materials, using materials with lower emissions intensity. So looking up environmental product data sheets where available. You can often find sort of similarly priced materials that have very different emissions intensities. For example, like we do a lot of building closure work, so you're looking at different insulations, and the choice of blowing agent in a spray foam, for example, can dramatically change the emissions intensity of that product. So there's often options there if you just sort of dig a little bit to make some better choices. Durability, so making buildings and materials last as long as possible. And sort of my current focus is on retrofitting existing buildings. When it comes to embodied carbon in particular, the most sort of efficient building is the one that's already there. Most of the embodied carbon in buildings goes into the construction of the structure, so all the concrete and the steel. And most of that is not altered when you retrofit buildings. So that's a really sort of easy way to make a big difference. So how does adaptation now layer on to the concept of mitigation? Certainly in BC in the last year, there's been increasing focus on adaptation. We had our heat dome in 2021, which was the hottest heat event ever recorded in BC history. And then that was followed a few months later by the atmospheric river, record levels of flooding and damage and cost the province. So this is really a hot topic now. And so I just wanted to share a couple of resources that are available to you. And then I'll dive into a few examples of how you can kind of combine all these considerations into our projects. So this is a resource, it's called the Climate Resilient Buildings and Core Public Infrastructure. So it's an initiative by NRCan to assess the impact of climate change on climatic design data in Canada. So it kind of compiled all the latest science around shifting climate scenarios, and it makes recommendations for how to apply these to design criteria. And they have varying confidence levels on certain climatic trends. So in terms of warming, for example, it's virtually certain that our climate is warming, and they have sort of recommendations on design data that you can use depending on the projected life cycle of the building. So how long you think the building is going to be in place. And you can also sort of make some judgments around how critical the building is. So you can assume a more conservative climate change scenario or a less conservative one, depending on sort of the criticality of the building. So this is a really great resource. They have sort of tables for most of the major climate zones, and you can kind of pinpoint design heating degree days and temperatures and whatnot. And there's some other factors like wind pressures, for example, that have been identified as we have very low confidence in how those are going to change. So it's a very good resource for kind of going through like what we know and what we don't know. And here's how you can incorporate that into your design. The other resource that I wanted to share is the Pacific Climate Impacts Consortium Future Morphed Climate Design Files. So in BC now, the building code still prescribes using historical weather files, although we've done a lot of studies looking at sort of current and future weather. And I think most of us know that the historic weather of the last 30 years is not really the same as what we're experiencing today. And it's certainly not what we're going to be experiencing the next like 20 or 30 years. So this is a great resource. They've now populated it with many locations across Canada. It's an open source, so freely available. You can go and look up your location. You can download whether you want to look at 2020s, 2050s, 2080s weather files, and then you can just plug those into your energy models. So really great resource. Okay, so I'm going to show you just a few project examples. So this is a study that we did with the University of British Columbia, really to advance our thinking around overheating. In British Columbia, we have, especially since the heat dome, an acknowledged crisis in that most of our multifamily buildings in the province were not designed with mechanical cooling. I think that's probably less the case in Ontario, although I have heard that there are still some older multifamily buildings in Ontario that don't have cooling. And many of the people who died in the heat dome died in their homes. So we've done a fair bit of work around sort of how we understand overheating, how we model it, define it, and how can we modify our buildings to better manage overheating and reduce those health risks. So this is really just building on my last slide around the future climate files, where so this is a typical like 4-story multifamily building built in the 1970s or 80s, very common building type in BC. And we just said, okay, what are the historic weather files? And we build a model of it, and then we kind of run these different scenarios, and we say, okay, well, we plug in the historic weather files, what does it say is happening in terms of overheating the building? And it's, basically saying there are 321 hours in the warmest suite that are considered overheating, which is based on an ASHRAE 55 acceptability limit, which in July is around 27 degrees. But then when you plug in even what's considered to be sort of average weather for today, you see that goes up. And then by 2080s, you're close to 3 times the number of overheating hours. The peak temperature has gone up from 32 to 37. But interestingly, during the heat dome last year, people were seeing temperatures around 40 degrees in their units. So this scenario is, these weather files are based on averages. So they kind of clip the extremes. So using something like this as a sensitivity test and a design is actually pretty reasonable. So this is the same study, but we are kind of taking a slightly different angle. We're testing solutions, and we're testing the robustness of solutions. So in this case, we modeled a new high-rise multifamily building that has mechanical cooling. And so this is sort of the hottest week in BC. We plugged in a 2050s weather file. So this dotted line here is the outdoor air temperature during that hottest week. So we're getting up to, 33 degrees, dropping in the evening. And then the blue line is what the operative temperature in the suite is. So you can see we're kind of just chugging along at, 25, 26 degrees, which is quite comfortable when you're in the middle of the summer. And this is what you'd expect because you have a mechanical cooling system and you've designed it for that. But we didn't do anything else special in terms of like managing overheating. There's no shading or anything. So we said, okay, well, if we take this building that meets current building code, and we now say, okay, there's a power outage during this week. And let's say there's also a wildfire event and people are keeping their windows closed, which is not an unusual situation in BC these days. What happens to this building? And this light blue line is now what the interior temperature does in that scenario. So not only are you significantly warmer than you were with cooling by, was that something like 12 degrees, you're also warmer than the outdoor temperature. So the fact that people aren't opening their windows, So you've got the solar gains combined with the internal loads that have nowhere to go. It's just compounding the effects. And this is, you know, getting into the high 30s, which is definitely a health risk. So then we say, okay, well, let's go back and revisit our design and see if we can do anything about this. So we went back to the drawing board and said, okay, well, let's add some operable exterior shades, and let's add a coating to our windows to reduce the solar heat gain that's coming through the glazing, and see what happens. So then if you do that, turn off the power, close the windows, this orange line is now how the interior temperature trends over that week. So it's a very significant improvement in terms of passive survivability in those conditions. This one is a kind of maybe a more practical example. A long-term care facility on the island, they came to us and said, hey, RDH, we want to replace our window systems. We recognize their end of life. They're not performing anymore. And can you do some costing for us? So we said, sure. Can we also do an overheating analysis? Because this facility also does not have mechanical cooling. And we'll look at energy, and we'll consider future climate, because this window system is going to be in place for at least the next 40 years. So I think, you know, let's understand how it's going to perform in 40 years as well as now. So we looked at 4 options. So the nominal upgrade, which is kind of what was sort of the base option, was to install a new self-supporting window wall, metal frames, code minimum thermal performance. And then we looked at an option that had a low solar heat gain coefficient coating on those windows. And then we looked at a higher performance option with improved thermal resistance. And then we did one 4th option that was the nominal upgrade plus exterior fixed shading. And I just wanted to show sort of a snapshot of some of the results, just to show that, you know, thinking about some of these issues together, I think allows us to give a more complete picture for the owners to make an informed decision. So what you're seeing here is the 4 options down the side. The capital cost for the window replacement. The marginal NPV is basically counting for changes in energy cost and carbon tax compared to the nominal. So a positive NPV is generally a good thing. And then we also added a column where we looked at the reduction in overheating days in this case. So you can see there's it's a fairly considerable reduction in the number of hours with each of these 3 options. The interesting thing in this project was we did this pricing like it's about a year ago. So definitely some volatility around like COVID supply issues, but we were surprised that the high performance fiberglass window system actually came in cheaper than the nominal. So kind of across the board, that was a no-brainer. And in retrospect, we might have then looked at high performance plus shading, but we didn't expect the high performance option to come in so much cheaper. But anyway, side note. And I just have one last example I wanted to share, again, to kind of show how we can sort of hold all these things in our minds, all these sort of sometimes maybe seemingly competing considerations, and come up with solutions that meet most or all of the criteria. So this is a 4-story, 3/4-story multifamily building in Vancouver. We're doing a deep retrofit design and implementation working with Fortis BC. So it's a comprehensive enclosure, mechanical systems upgrade and renewal. The existing building has no cooling, and most of the residents reported that they're way too hot in the summer, and the owners want to add cooling as part of the project. But at the same time, the project goal is to reduce emissions by 50 to 80%, and then also reduce energy by 50%. So can we come up with a cooling solution that doesn't sort of compromise those goals. So again, I'm going to share another sort of engineering spreadsheet here, because we love our spreadsheets, and just to kind of illustrate how we might go about this and present results to owners so that they can make sound decisions. So what you're showing here is this light green is our preferred bundle, which is our deep retrofit without cooling. And then across the top, we've got sort of electricity impacts, total energy impacts, energy savings compared to the baseline, EUIs, and then emission savings over here. So our preferred bundle is looking great in terms of our goals, almost 67% emission savings, 55% energy. And then we said, okay, well, let's look at a few cooling options. And packaged thermal air conditioner units, like easily available, very cheap, maybe a good emergency solution. But in terms, when you have time to plan, it's pretty clear that it sort of compromises some of our other goals. So the orange is indicating that by pretty much all of these indicators, adding P-tax makes everything worse. So we're kind of further away on our energy savings and our emission savings targets, mainly because these types of units are quite inefficient. They're going to use more electricity, and they often lead to simultaneous heating and cooling as well. So your heating use actually goes up. And then we're working on a couple of other solutions, and I'll just highlight this one here, which is using, because it's a forest project, we're sticking with gas systems. So we're looking at a gas absorption heat pump serving a water loop, and then having an in-suite electrically driven heat pump, water to air heat pump, to kind of maximize the efficiency of the main water loop. So this is a pretty good way to kind of provide all the functions. There is an increase in electricity use, but overall energy use is actually a bit lower, and emission savings are greater. So this is looking like a pretty good option. We're still kind of working through the details. But yeah, I just wanted to share sort of one of those examples where we're kind of combining mitigation and adaptation needs. So just to wrap up, I think we as engineers, we need to get comfortable, if we're not already, considering multiple objectives in our work. And that can include climate adaptation, passive survivability, emissions reductions, energy efficiency, many of the things that Mehdi mentioned, broader sustainability goals. And I am confident that there are solutions that balance all of these objectives. So I encourage you to remain hopeful that this is possible. And finally, I just wanted to close with, the thought that we need to both support and encourage our regulators to consider these things together. I know people look at BC as being the model. We have our challenges as well. We've had projects with different departments within the province. And this one department is responsible for adaptation, and they want to know the cost to do adaptation. And we feel as engineers, we can't just say, well, just do these things to maximize adaptation, that you have to think about mitigation too. But then it led to all kinds of back and forth around, well, you've incorporated costs for mitigation as well. So anyway, so it's a conversation for sure, and we're all learning. But yeah, there are a lot of great solutions out there, and I welcome your questions and comments. If you want to dive deeper into any of the other work we're doing, happy to chat about that. Thanks for listening.
Thanks, Christy, for your outstanding presentation. We'll jump to the next session of panel discussion. Their session will be moderated by Christopher and Camille. Back to you, Christopher and Camille.
Well, thank you very much, Christy, and we really appreciate having you here today and
finishing off the discussion strong, as well as Mehdi. And of course, we have Harshan with us today. We want to thank you guys, and we open the panel discussion to you three. So we have a number of questions in the Slido. And if you want to add questions, it's not too late. So for those watching and joining us this evening, feel free to join the Slido. It's in the comments in the chat there with the room code. So we have just around 7 questions, and I'll start with the most popular question. And feel free, Christy, Mehdi, or Harshan, to jump in and answer. So the first question is, how is industry sector regulation changes desired industry behavior to address climate change connected to regulated professions, such as individual behavior? So once again, how is industry sector regulation changes to address climate change connected to regulated professions?
Question is not quite clear to me, but I can attempt to answer it by mentioning that, let's say engineers have a set of professional practice guidelines that they have to meet in practice. What they can then do is work with other folks within the AEC space, the architectural, engineering, and construction space, to act as change agents, to be able to say that, our set of professional practice guidelines require us to consider climate change. And, we don't have to offer that as a mandate or a directive, but we can point to what are the co-benefits that we can achieve by addressing climate change holistically. How we can look at addressing not just GHG emissions, like as Christy mentioned, we can look at rather holistically and say, we're not just gaming for emissions, we're looking at energy costs, affordability, energy poverty, resilience, in a holistic manner. And to that extent, we get that message across to the broader groups of stakeholders. I think we can be successful. Hopefully that helps.
Yeah, I guess I'll add, I was also a little bit unclear on the sort of intent of the question, but in terms of, I think it's around how sort of maybe broader industry regulation relates to professional regulation. And I think where we've had in BC, and certainly what I believe, is that as professional engineers who are required to protect the public interest, that includes consideration of climate risk. And I think we're, I don't know if I'd say negligent, but certainly I think not doing a service to the public if we're not aware of what's happening and what the impacts of climate change are on the work we're doing, and communicating that clearly to our clients and the people that we're serving. So regardless of what the sort of the industry is regulating or what the codes are saying, I think we have an obligation as engineers.
Very well. Thank you, Harshan and Christy. And I think that really resonates with me personally, because to be an agent of change, I like how you worded that, Harshan, that, it's more of a holistic view, and it's more about not just what we can do individually, but as all of us together on a holistic level. So thank you very much, both of you, for answering that. We'll move on to the next question. So the question is, can you give an example of any cities setting carbon emission targets in quantitative terms? We are far off from net zero emissions now, states the anonymous writer. So a city that has a quantitative measure for setting carbon emission targets. Are you aware of either of a city of such targets?
I can speak to that, and Christy can jump in, and so can Mehdi as needed. For example, let's take the city of Vancouver. They have minimum energy use and emissions intensities that has to be met in Part 3 construction. in terms of quantitative, I don't think it gets any better than this. They have actually specified GHG intensity, that is, kilograms of carbon dioxide equivalent per meter square per year. So if it's group C occupancies, it's 3 kilograms per meter square, kilograms carbon dioxide equivalent per meter square per year. And for hotels and motels, it's 6. For certain different occupancies, it's 8. So essentially, what they've done is they've defined these GHG intensities, but rather than just aiming to meet those, we have to look at it rather holistically. So how can we also make sure that the thermal energy demand intensity, the energy used for space conditioning, your heating, for example, or, how is the energy, total energy intensity, everything including process and plug loads and appliances and stuff like that. How can we have targets around it? So they look at it rather holistically to make sure that if we are addressing carbon, that it doesn't exacerbate some of these other energy use problems. So maybe I'll pause there and see if any of the others want to add.
Yeah, I mean, thank you, Harshan. I would say by now, all the large cities around the world have emission targets for like economy-wide emission targets. They want to get to at least 80% reduction compared to the 1990 level. Some go to beyond that, like Toronto, for example, they go to net zero by 2050 or even earlier. And then when it comes to sector level emission target, then they have targets for new development. They have targets for existing building. They've got target for the transportation sector. So all that's available. The municipalities in California, for example, I think there's a great report available that kind of compares all the building codes, the voluntary building codes, and the municipalities in California, and how each one of them has different interpretation in terms of how they're going to apply it and what the requirements are, but they all set relatively similar emission reduction targets, or at least electrification targets for the building sector. So that's all available. I think the Rocky Mountain Institute might have a couple summary reports on this as well for those who are interested, but I can always point you to the Transform TO website. So that's Transform TO. And basically that kind of shows you how the city of Toronto looks at this.
Excellent. Thank you very much. And I hope that answers the individual's question. So next one is, how is the carbon footprint of all the building materials, starting with mining at the beginning of the supply chain, considered in these models?
I can make a start on that. And I also see there's another question about using recycled materials. The embodied carbon realm is a bit of a Wild West, I would say, right now. There are some standardized tools that are being used, like the Athena calculator, where you sort of plug in material types and it's done some calculations in the background. But yeah, like where do you draw the boundary? And it's, do you talk about the material coming from the manufacturing facility? How's it being driven to the site? Is it in a truck that's powered by diesel or gasoline? The driver, what did they have for breakfast? Like, you could kind of go on forever. So there's some tools like Athena, and there's I'm blanking on the other one that's quite popular right now, but they do sort of set some boundaries, and they have a lot of standardized values for things, and then you're just putting in quantities for, like, say, the amount of concrete, the amount of steel. I will also say they only consider structure and building enclosure currently. So there's been, a couple of studies lately attempting to quantify the embodied carbon of things like mechanical systems, which are just have so many different parts and pieces that it's very challenging. So I would say, yeah, those like recycled materials can be considered, although sometimes recycling is actually more intensive in terms of like energy and emissions than creating a new product. But it's all around kind of defining what your boundary condition is and kind of how far up the chain you're willing to go. But if you kind of set the same boundary for, say, you want to compare concrete versus wood for structure, for example, if you set a consistent boundary for both, then that's a good comparative tool for the relative embodied carbon impacts, as opposed to having like a definitive, this is the embodied carbon emissions of the building. That makes sense.
And the City of Toronto also, in their version 4 of the Toronto Green Standard, they have requirement for reporting of embodied carbon and doing life cycle assessment analysis of new development as well. And I think they've set certain standards and certain requirements for new construction to meet.
Thank you for highlighting that, Mehdi. Definitely Toronto's been trying to do a lot on the forefront of this, and we appreciate that. So your insights have been very beneficial this evening. The next question is, do building regulations prescribe only qualified persons to do the work? Example, demand side legislation to ensure professional accountability and avoid greenwashing.
Yeah, I can attempt to take that. I see there's a chat, item there that talks to architects and engineers can have best guidelines, but there's no demand side legislation. Then there's an opportunity that they can lose out on work, from people that underbid and win projects. In BC, how it is worked out is that we have the code mandated letters of assurance that all the design team professionals have to sign off on. And this is true for Part 3 buildings. In those professional assurances, there are line items regarding adherence to energy codes and standards. And things like energy step code are integrated into that. So the architect, the electrical engineer, the mechanical engineer, all the folks that feed into meeting the energy performance requirements have to work collaboratively and follow the professional practice guidelines that have been established by EGBC and AIBC to sign off on these professional assurances. So that kind of levels the playing field. If we look outside of the Part 3 context, even in Part 9 buildings, there are requirements. If a community has adopted energy step code, for example, then an energy model has to be done. And that model has to be done by somebody who's qualified as an energy advisor. And this is the program ran by NRCan. So they have to meet the certification requirements. And only then they can be engaged to provide work on energy modeling. And there are compliance forms available that local governments are able to utilize to make sure that these requirements are met. So it really levels the playing field, and it doesn't create a sort of a two-tier system where folks that are not properly qualified are able to take on this work. It simply, after a certain point, simply becomes a case where if you do not have the training, experience, qualifications to take on this work, you simply miss out on market opportunities.
Yeah, I just wanted to add on maybe that comment in the kind of the chat about professionals only having so much influence. And I totally agree. In BC, a lot of the great work we're doing is with early adopters, the people who have successfully accessed funding We're doing work now to inform the alterations code for existing buildings, which we hope will have some energy and emissions requirements attached to it. And I think there's broad acknowledgement that there's going to be a significant segment of the industry that's only going to move when they see that they're going to have to. And we can encourage that along with like additional incentives, like what Washington State did with their existing building regulation was, they announced the targets with several years advance notice. And then they put a whole bunch of money to anyone that wants to access grants to do the work sooner, as a way to sort of spur the industry on. So I think that's what we still need in BC, certainly around existing buildings. I think we're a bit further ahead on the new building side. But yeah, they have to go hand in hand, I think, for sure.
Excellent. Thank you very much, Harshan, for taking us through the process. And of course, Christy adding the comments there. It's really insightful to have that. Let's move on to the next question. So it's, how do we transfer all the amazing policies from BC to other provinces? And I applaud this question. However, I'd open it up to all three of you to answer this one, if possible, from your own perspectives.
Yeah, I can start, and I'd invite Christy and Mehdi to chime in. The opportunities are there. For example, if you look at the NECB, it has the performance path to achieving energy and emissions performance. All that needs to be done is, and the national model codes, I take it, it's evolving to include energy performance requirements as well. And what then needs to happen is that provinces will have to sort of adopt these requirements into their provincial building codes. And there are several ingredients needed to kind of implement this. If we look at the kind of structure that exists in BC, there is a Energy Step Code Council, and underneath that there's a technical subcommittee, a local government peer network. There's a network that supports the building officials. All these structures need to be enabled, and it needs to be working together to make sure that there's a coordinated approach to achieving energy and emissions requirements. And it's just a matter of will, because the model is already there. It's just a matter of taking it and applying it.
Very good. Mehdi, Christy, do you have anything to add to that?
No, that was well said. I think within the building sector, the building codes are in the control of the province, not the cities. So if for example in Ontario the province doesn't want to take on more stringent codes, then municipalities have very limited leverage right there. And that's just for new buildings or existing buildings that are going to go through extensive renovation. But then the existing building side, that's also another challenge, because then again the municipalities can't do much unless the province steps up and sets such requirements.
Yeah, I guess I'll just add that it can be pretty powerful that there are regions that have kind of solved this in a way, and I think BC's maybe partway there on some of the policies, like the new construction regulations. But there's places like Washington who has kind of solved the issue for existing buildings, or at least they're in the process of it. And there's a very well-defined, publicly available sort of how they've defined their legislation, what they have exemptions for, how they prove compliance. And then New York City, which Mehdi talked about, is another great example where they followed an emissions approach. So yeah, I often look at some of those other leading jurisdictions and regions just as proof that this can be done, because I think sometimes it's like the hesitation is like, how do we even start? We recognize this is an issue, we want to do something about it, but it just feels so daunting. It's like, well, here's 3 examples that, you know, have really great documentation that you can follow along and kind of demystify it a bit and make it seem more achievable and doable.
Excellent. Thank you again. I believe that's the end of our questions on Slido. We've answered the other 2 on the board here. So I do want to thank each one of you, Christy, Mehdi, and Harshan, for answering our questions during this panel session. I also want to take this opportunity to provide some closing remarks. And if there's any other additional questions, please feel free to email us or get in touch with our group. So with the closing remarks, I do want to say that at PEO, we are taking a little bit of action towards this. What's happening is on Monday, this very Monday, a survey is going out to all professional engineers, to the chapter leaders, and they're going to be working on kind of broadcasting it. But it's a 2-second survey, well, maybe a 20-second survey. It has 2 questions, and it's, are you concerned with the lack of climate change guidelines set out by PEO? And do you support PEO developing a practice guideline on adaptation, mitigation of climate-specific risks to engineering? So it's a 2-question survey, and it's a yes, no, and we encourage all of you to, when you do receive it, if you do receive it, to take the 20-second survey and spread it across, because this is the first time we're taking the temperature and seeing the public interest of PEO's license holders. And of course, thank you, Marilyn. Marilyn Spink is actually with us tonight on the chat. She's a former PEO council member as well, and has been instrumental throughout the years at PEO Council. So thanks for joining us today, Marilyn, and contributing to the chat. She's mentioned here that it's already on the website, so this is fantastic. So I do encourage you all to take the survey when you have a few moments, and this will literally be the first steps towards bringing some sort of climate action or climate change to the attention of Council. Thank you again, and I'll pass it on to David Lapp, who will be giving us our closing remarks for this evening.
Hi, everyone. It's David Lapp here. I'm actually in the United States at the moment, and so I'm trying to participate here as best I can. Just wanted to, first of all, thank all the speakers for their excellent presentations and for the excellent questions that were asked. I think it's pretty clear that climate change is a public health and safety issue, which means that as engineers and through our code of ethics, we are obligated to address as engineers. And how do we do that? Well, partly is being a professional engineer and the obligations that our code of ethics includes. And that includes, of course, in this case, consideration of climate change in our practice. And one of the things I think that is very clear is this is a rapidly evolving area that needs to be tracked. It's not something that you can kind of look at even every few months because there's things happening. And one of the areas where it is happening quite considerably is in codes and standards and practices. These are changing rapidly, and one of your obligations as an engineer is to keep up to date on local codes and standards and practices. So I think this is a message from this seminar tonight that one should be keeping track of these things, even as in the absence of any practice guidance in this area in Ontario. You just need to do this to fulfill your code of ethics. That being said, of course, practice guidelines would be welcome in Ontario. We have BC's done a number of well-developed ones. There's also ones at Engineers Canada that relate to this at a national level. So I would encourage folks to look at those guidelines and use them as the basis for engaging in this issue. And one of the things, of course, that I think PEO can do in the future going forward is to promote and, in fact, offer events around professional development of these, of this area of practice. And so this webinar series is one of those, but I think there's other opportunities as well. And I'm hopeful and would encourage PEO to, as part of its future planning and engagement, to plan to support these things and to publicize opportunities for Ontario engineers to learn more, because we're behind in the sense of knowing what is out there and what's going on. Obviously there are practitioners in Ontario and elsewhere that are deeply involved in these subjects, and we hope that we can, through these types of events, enable them to offer their expertise and experience to the others that are getting into this area. So I'll just say thank you very much to everyone for another excellent webinar. And I know we're looking at one in the water sector in a few weeks of a similar thing, and wish everyone the best, and thank you again.
We still have a section that's very important, where invite action to express our appreciation for all the group members. Action.
You're on mute, Harshan.
Thank you, sorry. Good evening, everyone. I would like to, on behalf of all the participants and organizers, I would like to appreciate our valued speakers that allocated their time to share with us their extensive experiences in a well-prepared presentation. In order of the presentation, our speakers were Harshan Radhakrishnan, Manager of Climate Change and Sustainability Institute, Mehdi Hosseini, Senior Engineer at New York State Energy Research and Development Authority, and last not least, Christy Love, Principal from RDH Building Sciences. Also, we would like to appreciate your contribution for this meeting, and also all the participants that they listen to our presenters, and with participation in Q&A, basically they made this meeting interactive. And last not least, I would like to thank first organizing group AdHocClimateChangeGroup, lead chapter Professional Engineers of Ontario, West chapter, and our sponsors, Professional Engineers of Ontario, East Toronto chapter, York chapter, and Peterborough chapter, Toastmaster International, Scores Speaker Club of Ryerson Engineering, Society of Women Engineers, Canada, Ottawa, and Toronto, and Toastmaster International Tech's Toronto Engineer Club of Speakers. And last, Institute of Electrical and Electronics Engineers, Peterborough section. We thank you all for your participation and having such a wonderful meeting. Thank you.
To wrap it up, I would like to express my sincerest appreciation to all the guest speakers, Harshan, Mehdi, and Christy. Thanks for your contribution to today's seminar. Climate action is an urgent and in-need field for Ontario engineering society. Is not only about the business for regulators or engineers. So there is still a long way to go for us. If you are inspired by today's seminar and want to keep updated of our next events, please subscribe to our YouTube channel for previous seminar recordings and follow up linking page for upcoming events. If you have further questions and want to join our group as a member, please reach out by email that we shared in the chat box. So thank you all today for your participation. If you are still online, please turn on your camera, and we want to take a picture together for the final closing. So please turn on camera, don't be shy. 3, 2, 1. Mel, 3, 2, 1. We're waiting for someone. Yeah, okay. Okay, thank you today. And I will officially close the meeting Thank you for participation and good night.
Thank you very much. Have a good night.
Thank you. Bye.